Thank you, Sahani sir, Dr. Sandeep Saidar sir, and Dr. Manish Asad. Good
Who is the
evening,
who is the speaker for today, sir?
Suraj Singh Bhadoria.
Okay, sir. I am making him the co-host now,
Okay, sir.
and you the host.
Yes, sir. Good evening, good afternoon, and good morning. This is the 1637th day of continuous webinar conducted by International Forum for Promoting Homeopathy. Today, our guest is Dr. Suraj Singh Bhadoria. And let us begin the session with 1 minute silent prayer. Thank you all. The International Forum for Promoting Homeopathy comprises of homeopathic lovers, students, and doctors. We have 3 sessions every day. The first session of the day is already over in Hindi from 7:30 to 8:30, and from 8:30 to 9:30, the international session in English, and 9:30 to 10:30, local language session in Malayalam. We are uploading the videos of the same on the very next day itself so that those who miss the sessions can watch it again. You can subscribe the same without paying any money. You can share it with your friends, whether it is a homeopathic lover or student, it doesn't matter. The purpose of this forum is to take homeopathy to each and every home around the world. And we are lucky to say that we have presentations from 65 countries, doctors as well as eminent personalities from different part of the world. And let us come to today's session. We have with us Dr. Suraj Singh Bhadoria, and Dr. will be talking as an assistant professor, Department of Homeopathy, Pharmacy, Pearl Institute of Homeopathy and Research, Vadodara in Gujarat. And he is an MD. He has completed his MD and now doing a PhD for the last 2 years. And the subject of discussion today is nanoparticles in the homeopathy. So we proudly welcome Dr. Suraj Singh Bhadoria.
Before Dr. Suraj speaks, let me say a few words about uh, our Vice President, Dr. Saji Kudiyat. Today, myself and Dr. Saji Kudiyat were whole day, for the last 2 days. We have spent time together at our World Homeopathic Science Congress. And our Vice President, Dr. Saji Kudiyat, he was also present, and we have good discussions about the promoting this forum more and more for more and everything. So thank you. And Suraj Singh Bhadoria is definitely a very beautiful, grand speaker. I welcome you, Suraj, and you can start your session now. Thank you.
Thank you, sir. Am I audible, sir?
You are.
Can I share my slides, sir?
Yeah, yes. You can share. You can share.
Visible, sir?
Yeah.
Okay. So first of all, good evening to everyone. Today, this topic is very, very important for us because nowadays we have this nanotechnology, which gives you a very different level of research experience and different types of conclusivity in our experimentation. So today we are going to discuss this nanoparticles or the nanotechnology in the field of homeopathy. Now, starting with this nanotechnology, first we will discuss what are nanoparticles. Now, what are nanoparticles? Generally, these nanoparticles are very ultra fine and minute particles. They are very, very invisible and smallest particles which are not seen by our naked eye. And this particle, the range is in between 1 to 100 nanometer in diameter. So that is the range of nanoparticles. When we talk about this nanoparticle, so in micron, it lies in between 0 to 1 micron. So in nanometer, it lies in between 1 to 100 nm, and in micron, it lies in between 0 to 1 micron. So these are very, very ultra fine structures
ultra fine particles which are not seen by our naked eye, but they are showing their efficacy and their action on a smallest and the particular entity in the living organism. Clear? Now, when we talk about the properties of nanoparticles, so the nanoparticles are generally, they are distinguished from the microparticles, and they are very fine particle, very smallest particles, and these smallest particles, they derive from their different physical property, different chemical properties. So when we talk about these nanoparticles, so they have physical property which is different from the coarse particle, which is large in size, and they also differ in their chemical property as compared to the coarse particle, which lies in between 100 to 2500 nm. So the coarse particle is generally, it is very large and they are more bigger than the nanoparticles. So generally this nanoparticles, they have both physical property as well as the chemical properties, like the colloidal particles. These smallest particles, they are used for various aspect in the field of science, like optical effects, like electrical properties. So there are so many properties of nanoparticles which are very, very useful for any type of research or scientific evidence. When we talk about the nanostructures, so generally they are widely spread in a nature, and they are studied in a different classification of science, the classification of chemistry, classification under physics, classification under geology, classification under biology. So these are the different classification, different aspect of the nanoparticles, which are going to show their different chemical, different physical, different biological properties along with the materialism. With this transition, this nanoparticles generally, they shown their property in different aspect as compared to the atomic structure and the molecular structure. They are an important component of atmospheric pollution. When we talk about pollution, so there are so many invisible, minute microstructures which are having ingredient like paints, plastics, metals, ceramics, and magnetic products. So they are very, very minute, and they have all these types of properties. The production of nanoparticles with specific properties is a branch of nanotechnology. So when we talk about nanoparticles, when we talk about the properties of nanoparticles, when we talk about the history and development of nanoparticles, when we talk about the various factors and the characteristics of this nanoparticle, so it comes under the nanotechnology. So nanotechnology is a huge branch which deals with the study of nanoparticles. When we talk about the IUPAC classification, which is International Union of Pure and Applied Chemistry, so according to IUPAC in 2012, this nanotechnology, it is derived as a polymers. So they are a particle, the size of this particle is around 1 into 10 to the power of -9 and 1 into 10 to the power of -7 m range. So this is as per IUPAC classification. Whenever we talk about any smallest size, any minute structures or the polymers, so the IUPAC classification is a very standard one. It reflects the range and the size of that particular microstructures. So this definition evolved from one given by IUPAC in 1997. When we talk about the history of this nanoparticles, so these nanoparticles are naturally produced by many cosmological, which is regarding with the cosmetic products, regarding with the external applications, geological, meteorological, biological processes. So these are the different processes through which the nanoparticles are originated. So they have a different branches, they have a different origin, they have a different background. for explaining this minute and the microstructure in terms of their properties, in terms of their efficacy, in terms of their pharmacological action. Because ultimately, why we are creating these microstructures? Why not the coarse powder? Because coarse powder, the efficacy of this coarse powder is always different as compared to the efficacy of this microstructure, which are nanoparticles. So the efficacy of these nanoparticles, they are more specific and specific to that particular element as compared to the action of coarse particle. Whereas the action of coarse particle, they act on the whole body of living organism. Whereas this nanoparticle, they act on a smallest cell of that particular living entity. So this is a difference between the action of coarse particle and the action of nanoparticle. Now, a significant fraction of interplanetary dust that is still falling on the earth at the rate of thousands of tons per year is in the nano range, nanoparticle range, and the same is true of the atmospheric dust particle. Many viruses also having that dimension of nanoparticle range. For example, when we talk about the coronavirus, so this coronavirus, the size is very less. They are also invisible, they are very minute, they are also having a specific action on a specific viscera in a living entity. So there are some bacteria, there are some viruses, there are some disease causing agent which in which their size is just similar as the range of nanoparticle. So they are very harmful, they are very like fatal. That's why in COVID-19, the coronavirus, the fatal rate is always high as compared to the other viral infection. So the size, whenever the size is very small, so the efficacy is more. Whenever the size is more, then efficacy is less. So the size of particle is always inversely proportional to the action of that particular particle. Okay, if the size is more, then action is not more. If the size is less, then action will be more. So when the size is going to reduce, their dynamic power, their qualitative assessment, it is going to more and more finest as compared to the coarse particle. When we talk about the morphological and the structure pattern of this nanoparticles, so they have a different shape. They have different shape in terms of nanorods, like nanospheres, like nanochains, like decahedral nanoparticles, nanostars, like flowers, like reefs, like wrinkles, like and nanofibers, like nanoboxes, like square, like cubics, like bottle shape. So they have a different shape. They have a different what we can say a crystalline arrangement. So it depends on so many factors. The shape and the size and the morphological feature of this minute particles and the nanoparticles, it depends on number one, the source where which we prepare the nanoparticles, the method from which we prepare the nanoparticle. The third one is their physical and the chemical property. The fourth one is some other accessory components along with the nanoparticles. Suppose when we talk about chemical method, so we have so many chemical ingredients like potassium perocyanate, sodium benzoate. So when we mix this chemical ingredient in a solvent system, so these particles are said to be a accessory particles or the components along with our main minute or microstructures. So all these arrangements and their crystalline formation, it depends on all these factors: the source, the material, the process of preparation, and their accessory component. When we talk about the shape of nanoparticles, so they are generally determined by intrinsic crystalline habit of the material. Because when we talk about material, so they have a molecule, they have atoms, they have ions. So this arrangement of intrinsic crystalline habit of that particular matter will give you the shape of the nanoparticles, and these are influenced by the environment around their creation, around their inhibition of crystalline growth, or certain phases by coating additives. In certain cases, we have the coating on that particular minute structure, coating by our oil emulsion, coating by our alcohol base, coating by our extract preparation. So they have a different coating. So on the basis of that particular coating, their crystalline arrangement and their crystal growth, it depends. because if there is oil base, so the crystalline arrangement is something darkened because the viscosity of oil is more as compared to alcohol. When we talk about the pulp, so definitely the viscosity of that particular pulp is less as compared to oil. So the crystalline arrangement of that particular nanoparticle is something different as compared to the oil. So the coating additives, it plays a major role in the formation of nanoparticles, the shape of emulsion droplets, miscellaneous, and some other pores inside the surrounding solid matrix. So these are the different morphological and different structures of nanoparticles. So whenever we prepare this nanoparticles, so they are in a different arrangement. They are in a different crystalline pattern. They are in a different segregation. They are in a different dispersion. So the level of dispersion, level of segregation, level of crystallization, these all things are included in these morphological features of nanoparticles. Next one is production. What are the procedures through which we prepare the nanoparticles? There are so many procedures. What are the procedures? Number one, mechanical method. Number two, breakdown of biopolymers, pyrolysis, condensation from plasma, inert gas condensation, radiolysis method, wet chemistry, and ion implantation. So these are the different methods through which we prepare the nanoparticles. Suppose in our homeopathy, when we talk about mechanical, so the process of potentization, for liquid potency when we do succussion, and for solid potency when we do trituration. So this process of mechanical process, it involves in the synthesis of nanostructures, nanoparticles in our solvent media. Clear? So this is one of the example in our homeopathy, because today our main theme of this seminar is nanoparticles in the homeopathy. As we know, our homeopathy are already ultra high diluted. It based on ultra high dilutions, except mother tinctures. So it is already above the 1 into 10 to the power minus 9 or 1 into 10 to the power minus 7. So when we talk about nanoparticles, so when we prepare this nanostructures in homeopathy, so it is something like a retrospective design. Because when we talk about ultra high dilution, so to explain pharmacodynamic and pharmacokinetic pharmacological action of that particular medicine is very difficult, and it is not accepted in a mass. So what we are going to create it, we bring this energy into some mass in terms of nanometer, in terms of micron, and this micron and this nanostructures, these nanoparticles, now they will give you evidence in terms of pharmacodynamic, pharmacokinetics, or pharmacological action. Clear? So in homeopathy, in ultra high dilution like 30, 200, 1M, 10M, we are going to back our retrospective design. But if it is mother tincture, which is already having all the atoms, ions, molecules, so we will go for the prospective design. So this is a process through which we can synthesize the nanostructures in homeopathy, because we have two main aspects. One is mother tincture and ultra high dilution. For mother tincture, we will go forward, that is prospective design. For ultra high dilution, we will reverse back, that is retrospective design, because we have to create some mass in our medicine so that we can show their pharmacological action, their pharmacodynamics and pharmacokinetics. Clear? So these are the steps for preparation of nanoparticles, nanostructures in the field of medical science. Now, when we talk about the characteristics of nanoparticles, so generally nanoparticles have different analytical requirements, which depends on the conventional chemicals for which chemical composition, concentration of such matrix. So these are very, very important. Nanoparticles have other physical properties that must be measured for a complete description, such as the size of nanoparticle, the shape of nanoparticle, the surface properties of nanoparticle, the crystallinity of nanoparticle, the crystalline arrangement of nanoparticle, the rate of dispersion of this nanoparticles in a solvent or in a base. So these are the different characteristics properties of nanoparticle. So what is the size of nanoparticle? What is the shape? What are the surface property? What are the crystalline growth of that particular nanoparticle? What are the rate of dispersion of that particular nanoparticle? So these are the basic characterization of nanoparticles. So whenever we prepare nanoparticles in our solvent or in our media, in any vehicle base, like sugar of milk, like alcohol, like distilled water, like oil base, so we have to know about their size, we have to know about their shape, we have to know about their surface tension, we have to know about their crystalline growth, we have to know about the rate of dispersion, we have to know about the rate of absorption also. So absorption means the concentration of these nanoparticles which are present in that particular solvent media. So this is also important characterization for the nanoparticles. Now, what are the methods through which we can determine this nanostructure in terms of nanometer, in terms of micron? So the main basic technique is spectroscopy. So in spectroscopy, we have this electromagnetic radiation. So this electromagnetic radiation, it determines the function of wavelength. So by the help of spectroscopy, we are going to determine their wavelength with the help of electromagnetic radiation. Clear? And it is very useful for some classes of nanoparticles to characterize the concentration, spectroscopy, concentration, size, and the shape. So these are very, very important in terms of spectroscopy. Whereas in X-ray or the ultraviolet, visible rays or infrared or NMR, which is nuclear magnetic resonance spectroscopy, it is used for the various dimension of nanoparticles. Clear? So in spectroscopy, generally we use UV light or IR or X-ray. So this radiation, this spectrum will give you the size determination and the shape determination and the basic physical properties of the nanoparticles. The light scattering method like laser, X-ray, neutron scattering, it is used to determine the particle size, with each method suitable for different size range and particle composition also. So suppose when we talk about the electron microscope, so they have two main varieties, SEM and TEM, scanning electron microscope and transmission electron microscope. So through this scanning electron microscope, we can also determine the size of particle and the composition of particle. Okay, in terms of carbon percentage, in terms of nitrogen percentage, in terms of oxygen percentage, in terms of hydrogen percentage, etc. So these are the particle composition. Some miscellaneous methods are electrophoresis for surface charge particles. Clear? So it is the major aspect of the determination of nanostructures. When we talk about XRD, that is X-ray diffraction technique, so it gives you the crystalline arrangement, the crystalline structure of this minute structure, as well as mass spectroscopy also give you the particle size of nanostructures. The particle counters for the particle numbers, it is also determined by the mass spectroscopy. Whereas chromatography, centrifugation, and filtration, these are the techniques which are used to separate the nanoparticles in terms of their size, in terms of their physical properties before or during the characterization. Because chromatography, centrifugation, and filtration, these are very basic one. So through this method, we are only determining the number of pigments. Okay, the separation in the nanostructures, in the nanoparticle, or some other physical properties. But when we talk about the particle size, the crystalline arrangement, or the different rate of dispersion or the particle composition, so it is not determined by this type of technique, chromatography, centrifugation, and filtration. It is determined by X-ray or neutron scattering or some other spectroscopy technique. Clear? So generally these are the common techniques which are used to determine the basic characterization of nanoparticles. Clear? Overall, when we talk about the commonly used technique, that is electron microscope, in electron microscope, SEM and TEM, scanning electron microscope and transmission electron microscope. So SEM is generally used for the liquid, not liquid like a solid preparations. Whenever we have the powder trituration, so we will go for the SEM analysis. When we have the liquid potency or the liquid solvent media, so we will go for the TEM analysis, that is transmission electron microscope. So on the basis of the physical property of our sample, on the basis of their chemical composition of the solvent, on the basis of their basic characterization of that particular solvent, we have to make sure our method of preparation, or we have to decide our method of identification. So this is the basic properties and the characterization of nanoparticles. When we talk about some other applications of nanoparticles, so generally there are so many ways through which we can use these nanoparticles. So they are generally used for the polymer reinforcement. They are generally used for the liquid properties turner. They are generally used for the photocatalysis in the breakdown, in terms of road paving, in terms of biomedical weapon, in terms of sunscreens or external or the cosmetic applications. So generally these are the various use of nanoparticles. When we talk about nanoparticles in homeopathy, so generally it is biomedical aspect. So what we are going to synthesize? We are going to synthesize the nanostructures in our medicine, in our drug, in our remedy, and this particular nanostructure or the microstructure, they are going to show their efficacy on that particular part of the living entity as compared to the whole. Why this nanotechnology and nanoparticles are different as compared to the ultra high dilution? When we talk about ultra high dilution, so they are going to show their efficacy from top to bottom, a holistic approach. Whereas these nanoparticles, they are showing to they are going to show their efficacy on a particular viscera in a living entity. So this is all about application part. Now afterward, these are our recent research work which based on the nanoparticles. So in first project, this is Echinacea nanoparticle. We create or synthesize nanoparticle in Echinacea mother tincture. So this is prospective design because it is already concentrated. It is having all atoms, ions, molecule, isotopic molecules, isomers. So we are creating this in a terms of prospective design. So this is a method of chemical composition. So we used potassium ferrocyanide as a biocatalyst to synthesize the nanostructure, nanoparticles in the mother tincture of Echinacea by the process of potentization. So when we mix this biosynthesis or biocatalyst in our mother tincture with the solvent system, that is distilled water as a vehicle, afterward we go for the potentization. So this is liquid. So we use the suction process for the synthesis of nanostructure. So this is Echinacea nanoparticle in 2 μm, in 2 micron. This is Echinacea nanoparticle. It is bigger in 15 μm. So you can see in different range of micron, the size, the crystalline arrangement, the physical properties, they are also differ. So the range of that particular nanoparticle, it will also give you the specific physical, specific crystalline growth, specific chemical property also. When we talk about this in a 30 μm, so you can see this is just like a rod shape. So in 30, it is rod shape. Whereas in 5 micron, it is just like a small crystal growth. So these are in a different pattern. So in a different range, in a different particle size, they show different arrangement, different crystalline growth, different rate of dispersion. So similarly, next slide, you can see this is just like a glass of bottle driven in a sea or a water. So this is in 5 micron. Whereas in this 5 micron, when we go for this resolution of this particle size, so it is just like a broken glass-like appearance. So these are the different arrangement of nanoparticles in Echinacea Q. This is ADS scanning. ADS scanning generally determines the compositional value of this particular nanoparticle. So what are the composition? Now you can see in this graph, the carbon is around 81.4% in weight, and oxygen is around 15.7, and potassium is around 1.7, and ferric, that is iron, is around 1.2. So this is the spectrum of EDS scanning. So when we do this characterization of nanoparticles, so we have to also know about their compositional value. What are the some elements in that particular nanostructure? So the basic elements are this: carbon, oxygen, potassium, and iron. Now these are the values. Now you can see in EDS scanning, the weight percentage is around 81.42, 15.67 for oxygen, potassium is 1.67, iron is for 1.23. So the more is carbon atom and the less is iron. When we talk about this EDS scanning in terms of atomic percentage, so the carbon atomic percentage is around 86.65, which is more than others. Oxygen is around 12.52. Potassium is around 0.55. Iron is around 0.28. So out of 100%, these are the distribution of basic compositional values in that particular nanostructure, which is created or synthesized in the Echinacea mother tincture. Whereas in next research, it is our Azadirachta indica nanoparticle. So we synthesize this nanostructure, nanoparticles, the microstructures in the Azadirachta indica Q, which is prepared by the bark. Okay, so generally you can see in 3 micron, these are the crystalline size and the shape of the nanostructure. So in this pattern, you can see around 813 nm. It is around 778 nm. It is around 813 nm. It is around 741 nm. So these are the different crystalline size of that particular nanoparticle of Azadirachta indica mother tincture. Now this is in 1 μm. So this 1 μm, when we talk about nanometers, so 1 μm is equals to 10 to 1000 μm. Okay, so these are the range of nanoparticles. So you can see this crystalline arrangement of nanoparticle, it is just like a cluster. So this is the Azadirachta indica Q. When we talk about sunflower, so we also create this nanostructure and nanoparticle in sunflower mother tincture. Generally it is around 1.21 μm, 2.19 μm, 158 nm, and 222 nm, and 178 nm. So these are very minute structures which are seen in the sunflower. So these are the various process and the various steps through which we synthesize this micro and the minute structure in a different solvent media. Some of the procedure are physical, some of the procedure are chemical, some of the procedure are the bio weapon, some are the procedure of the potentization, some of the procedure are the polymeric chain reaction. So these are the different process through which we prepare this nanostructure. So these are scanning by SEM. Okay, so this all is scanning done by the SEM analysis, and this SEM, it is available in our micro nano research and development in Parul University. So whenever we prepare this nanostructure or the nano solvent, so we will have this analysis under SEM, scanning electron microscope. Whereas in other, you can see these are again the nanostructures in sunflower. So you can see this size 1.37 μm, 1.50, 126 nm, 132 nm, 1.29 μm. So these are the different size and the ranges of nanoparticles in this crystalline arrangement. Now you can see the another one is this is nanoparticle of potassium ferrocyanide. So this potassium ferrocyanide, these are a biocatalyst. It is a chemical ingredient. It is generally used to synthesize various minute and the micro structures, microfilaments in the solvent system. So it is in 150 μm. So in 150 μm, you can see this large size, just like a piece of stone. Whereas beside of this, these are very minute and microfilaments. So when we focus on this particular particle, so you will have a different range. Clear? So this is a view in 150 μm. So it is potassium ferrocyanide nanoparticle. This all analysis comes under SEM analysis, that is scanning electron microscope. Now, these are our student research activity. These are our first year BHMS students. They are not only preparing the solvent system, not only preparing the nanoparticles, they are also determining the physical and the chemical property and the basic characterization of the nanoparticles with the help of faculty and a team of micro nano R&D cell in our Parul University. So these are our first year students. This is like not feasible in a generalized manner, because in first year students are just they are knowing about anatomy, physiology, pharmacy in general, basic pharmacy, organon of medicine, materia medica, but they are also have that potential to create and to form and to formulate a new solvent system. And not only preparing this, they are also going to show their efficacy, their effectiveness in terms of pharmacological action, and also their basic characterization of nanoparticles. So this is very, very important for us. When we talk about nanoparticles, so we have to also know about their basic properties. Now, this is our MD students or faculty in UG. So this is just like a collaborative research work. So in MD, we will also have that type of facility and the research area in terms of nanotechnology. They were preparing the nanoparticles in Seneca officinalis 30. So when we talk about 30, so it is retrospective design because it is already ultra high diluted. Clear? So when we gave the sample of Seneca officinalis 30 in the SEM analysis, so in between 1 to 10 μm, we will have no particle distribution and no specific crystalline growth. So we have to synthesize it. We have to create some mass in terms of nanometer, in terms of micron in 30 C. So this is Seneca officinalis 30 nanoparticle, which is in the oil base. So this oil is basic covering of this nanoparticle. Now, this is our again second year BHMS student Manan Shah. So he is also synthesizing the nanostructure nanoparticles with the help of potentization in the mother tincture base. So this is again an important aspect in our BHMS students. They are preparing it, they are synthesizing it, they are creating some chemical and the physical properties with this microstructure, and they are also using this nanostructure nanoparticle in terms of pharmacological action. These are our first year students, first year BHMS students. They are synthesizing nanostructures, nanoparticles in mother tincture base. So this is just like a prospective design. Afterward, we will also go for the article publication, because after every research work, the publication plays a major role. In which journal, in which category, in which discipline. So this is very, very important. So we also publish this nano research work in Comprehensive Advanced Specific Summarized Studies for Homeopathic Sciences, CAS Studies. It is a name of journal. And the title of this research work is Synthesis of Nanoparticles from Helianthus NSQ, that is sunflower. So this is prepared by the process of chemical procedure under the dynamization. So the main author is Patel Disha Ishwar Bhai, Shah Divya Tejas Bhai, and Monimala Pramanik Madam is our co-guide for this research work, and Purav Desai sir is our Dean of Faculty of Homeopathy in the Parul University. So this is already published in CAS Home Journal. Another publication is Synthesis of Echinacea Q nanoparticles in olive oil base by the process of potentization under standardization with the help of SAM analysis and also determining the compositional value of this Echinacea mother tincture nanoparticles. So it is already published in International Journal of Chemistry Research and Development, which is one of the peer review international journal. And the main author of this publication is Pratibha Kane. She is professor in the Department of Repertory and Case Taking in Parul Institute of Homeopathy and Research, Parul University, Vadodara, Gujarat. And Parul Patel, she is our trustee in Parul University in Department of Organon of Medicine and Homeopathic Philosophy. So this is already published in international journal. Another research work, that is synthesis of nanostructure or nanoparticles in the complex preparation by the two mother tincture. One is Stepis agria mother tincture and another one is Cantheris mother tincture under the influence of potentization. So this is already published in International Journal of Advanced Chemistry Research, and it is one of the peer review international journal. And the main author of this research work is Bharya Drashti Umesh. So she is our first year BHMS student. So this is a very challenging job for us to nourish our BHMS students in terms of research, in terms of nanoparticles, nanotechnology, in terms of publication, in terms of patent formation. So this is very, very difficult job. So we also have that facility. We are thankful to our Parul University for providing such a huge platform for us, not only for faculty, for all team members, for all students, UG students, PG students, PhD students, because as per new CBDC curriculum, now research included in our BHMS curriculum, BHMS course also. Previously, it was only in MD course or PhD. But as per new CBDC curriculum, it is included in our UG course also. So why research is important in UG? Because this research will give you an idea about the research proposal, about the article preparation, about the method of research, about the quantitative analysis, about the qualitative analysis, about the hypothetical part, about the various phenomena in the research work. So these are very, very important in our UG students. So we are just starting this work with our UG students, with our PG students, with various faculties of repertory department, organon of medicine department, and medicine department also. So we are again very thankful for us for this platform to showcasing our research work, to showcasing our knowledge, and to have this what we can say a beautiful aspect in the field of homeopathic science. So thankful for this presentation. Thank you, sir. Yes, sir. Am I audible, sir? Sir, your voice is not audible. Hello, sir. Hello. Sir, your voice is not audible, sir. Okay, sir. Ask to unmute, sir. Okay, sir.
Thank you. Okay. Thank you, Dr. Suraj Singh Bhadoria. It's really a very good session indeed. And you really show the beauty of research in this field. And people used to say that homeopathy is a system which is unscientific. But you people, the caliber of you people are really coming forward with such a research work and showing that homeopathy is the best science in the world. And we can prove the medicine in our the medicinal part in our medicine in such an extent, and why still people are saying this is unscientific, but it is not. It is the pure science. And due to some technical problem, I was not able to talk in the first part, and now I can talk. As unfortunately my network was out of went away, and then I was then our host, our faculty become the host, and that's the reason why there was a lag in between. Sorry for the trouble. And now Muhammad Hassan, I want to speak to you. Yes, Dr. Muhammad, please raise your hand once again, so that we will allow you to unmute. Those people who want, yes, Ms. Muhammad Saiden, please unmute yourself. Yes, please unmute. Yes, you can
Am I
speak
audible,
now.
please?
Yes, yes.
Yeah, thank you. The question is, what about the nanoparticles toxicity? I have read more than a report about nanoparticle toxicity to the human cells. Does this apply to homeopathy products?
Sir, when we talk about this toxicity, so after the synthesis of this microstructure in our homeopathy, we are going for phase 0 study, for in vitro study for various bacteria like gram positive, gram negative, and candida albicans for fungal variety. And afterward, we go for the in vivo study, which is on animals. So for phase 1-0, it is just an ongoing process from our side. Afterward, we will define the toxicity of that particular nanostructure in our homeopathic medicine. And after this, then we will enter into the human trial. This is phase 1 study. So it is under process, sir, because we are just synthesizing these nanostructures with our BHMS students or some faculties or PG students. So after the synthesis, we enter into the phase 0 study, which is preclinical trial, by in vitro study, cell line study, by animal proving. Afterward, we will definitely showcase this in terms of toxicity. Then we will go for a human trial.
Yeah, sir. Am I ask another question?
Yes, sir.
Yeah,
Definitely.
thank you, sir. What about the oxidative stress of the nanoparticles in homeopathy? Did you plan or did you study the oxidative stress effect of nanoparticles?
No, sir. As we know, our homeopathy is already ultra high diluted, and when we talk about their bioavailability, so it is again unknown origin. We thought that it is 100%. So we are just in a initial phase to synthesize this nanostructure by the prospective or the retrospective design in mother tincture or ultra high dilutions. Afterward, we will definitely have this oxidative stress also, because in our homeopathy it is very something new kind, so that's why we are just in a initial phase for this.
Thank you, sir. Thank you, sir. Thank you.
Thank you, sir.
Sir, what kind you have? You already told that the paper was submitted to the scientific paper. That is, it is published in chemistry.
Yes, sir.
Department.
International Journal of Chemistry Research and Development.
Okay. That is from which part of the world, which is
Sir,
being
basically it is our first only the synthesis part, sir. Afterward, when we do this in vitro study or the cell line study or animal trial, in vivo trial, then we will do another publication in some other peer review international journal. So these are just like a distribution work, sir.
this international journal is coming out from which part of the world? From India or some other part of the world?
Sir, this is generally from India, sir. The main publisher is Actinic Publication. So they have a various and number of journal in a different multidisciplinary way. So these are the way to focusing the research work in a different domain. So Actinic is a publication for this particular domain, and this is a peer review index journal, sir.
Yes, that's why I asked the question, because I'm publishing a thing in a different department, that is particularly in the research department in chemistry, is something great, because we used to say we are, most of us are publishing in our journal itself. So nobody nobody is aware about all these things happening in homeopathy. So once you publish these things in a different international journal, people from different category will realize that, oh, homeopathic doctors can also do things, research work like this, and this kind of research work really take us to the forefront of the scientific communities. Thank you for your such great effort, because you have present various papers on different research in this field, and all the papers were really extra brilliant, I must say.
Thank you, sir.
I invite
Thank you so
Dr.
much.
Ambaresh sir to say a few words. As Dr. Ambaresh sir, you can speak. Can you
Thank
hear me?
you, Dr. Dhaneji. Hello, visible. Sound visible. Ah,
Uh,
thank you, Dr. Dhaneji, and congratulations, Dr. Suraj Singh Bhadoria. Really,
Thank you, sir.
all presentation is a dynamic and nice, beautiful. Describe the particles, nanoparticles. Knowledgeable presentation according to homeopathic medicine, nanoparticles, according to theory, disease, according to law of homeopathic, nanoparticles. So very, very thanks, Dr. Suraj Singh Bhadoria, and knowledgeable BHMS student, MD, etc. research work So very, very thanks. Thank you.
Thank you, sir.
Thank you.
What is the latest research work you are doing?
Sir, latest we are entering in this pharmacological action, sir,
Describe करता
in
है
vitro study, sir. So we are
जितनी भी
planning
होम्योपैथिक दवाई है ना
shown
नैनो
this
पार्टिकल्स
effect of
हाँ
nanoparticles
बीमारी के कारण भी नैनो
in gram positive, gram negative, E. coli, Staphylococcus aureus, and Candida albicans. So it is just on base, sir. So this is our in vitro study, sir. It is our next goal, sir.
Okay. Dr. Muhammad Saidan, you can speak now once again. If you and then you can say auto thanks to the session also.
Yeah, yes, sir. If we can prove the antibiotic effectiveness of the nanoparticles, this will be a Nobel Prize. Yes, sir. And thank you very much.
Yes, sir.
Thank you
Yes,
very
sir.
much. It is very valuable research. It deserves a Nobel Prize if we can prove the antibiotic effect of the nanoparticles with no side effects. That's spectacular. Thank you very much, sir.
Thank you so much, sir. These all are because of your blessing, sir.
Thank you.
Thank you, Dr. Muhammad Saidan and Dr. SURAJ SINGH BHADORIA, doctor. And those who attend the session, we have a wonderful session in this evening about a research paper published by Department of Chemistry, and that's Tomorrow we will have a session from Dr. Indranil Bhavatkar, and doctor will be talking about essential things in clinical form, eyes of law. That is, he is presenting something related to laws. In the Indian laws, which whether you can do homeopathy practice and how one can do, if at all any problem arises, how one need to approach the court like that. Okay. Thank you all. Good night. It's over to Dr. P. Shaila to moderate the Malayalam session. Thank you.